we'll explore the data types that MATLAB has to offer. We'll also explore how each one works and how you can use them effectively. For every data type, we'll cover the basic essentials, how MATLAB handles it, how to create variable, and the must-known operations for that data type. Plus, we'll also discuss common mistakes to avoid while using that particular data type. We'll also consider performance tips and will showcase practical examples to see each data types in action. So stay tuned to unlock MATLAB's full potential and supercharge your project. So now without wasting time, let's get started. In numeric data type, first we are going to explore double precision floating point. The double precision floating point, commonly referred as double, is MATLAB's default data type for numerical values. It's used extensively in engineering and scientific calculations due to its ability to handle large and small numbers with significant precision. Now let me tell you how it is stored in MATLAB. Double values are stored as 64-bit floating point numbers as per the IEEE 754 standards. This provides precision up to approximately 15 to 17 decimal digits. Now, after talking this much about double data type, the question comes to your mind is how to assign that data type to any variable. So to create double variable, you just simply assign a decimal or integer value to the variable and that's it. Let's say here we have taken two variables, a is equal to the value of pi and b is equal to 42. And now let's run. So we have got a here, b here, and here in workspace you can see the class of this data type is double. So these numbers are automatically being stored as double precision floating point if you do not assign any specific type of data type. You can perform all the standard arithmetic operations with double data type. Let's see here, we'll do some addition with this. We are taking c is equal to a plus b and let's run. So we have the answer of c and that is also a double data type. Let's add here. When you are dealing with double data type, sometimes you need to be very careful with this. When testing for equality between two floating point numbers, direct comparison using double equal to can often yield in unexpected results due to the precision errors. So there are this type of few things that you need to be careful when you are handling this double data type. Now this addition a plus b is equal to c is one of the type of practical example. But let me give you another example. There you just need to consider a task where you need to compute the square root of a number. And this is very common operation in engineering calculations. So now here let's find out square root of a, right? And let's run. And there we got a result over here. Result is equal to this, and that is also a double data type. So this is what all about double precision floating point or a double data type. And if you want to check whether your variable is of really double data type or not, then you can check this in the class of that variable. After this, we are going to explore another data type, and that is single. But before this, there is a quick short question for you, and your question is this: a double or a double precision data type is being stored as 32-bit or 64-bit floating point numbers. What is the right answer? Think over it and then write in the comment section. This will show how attentive and quick you are in answering. So once you are done with this, now let's move ahead. Now we are going to deal with single. So single is basically a single precision floating point. When you need to save memory and you can manage with the less precision, the single data type comes into play. It's the commonly used in applications like graphic processing or when working with the large matrices where high precision is not crucial. Basically, single data type values are stored as 32-bit numbers, providing roughly 7 to 8 decimal digits of precision. whereas in double data type the precision was around 16 to 18 or 16 to 19 decimal points, and here the precision is around 7 to 8 decimal points. So this much amount of compromise you're supposed to do when you are using single data type, but this much amount of precision is quite adequate for many practical applications, so no need to worry about that. Now if you want to create a variable which has single precision data type, then how can you do that? Now let's write that thing. So here we'll write a variable is equal to single into the bracket the value. Instead of directly writing value, we'll write single and then put the value in bracket, and this will assign single data type to this variable. Now let's run this thing and you can have a single data type variable. We'll write another variable b as single data type, and now let's run. The basic operations with single data type are similar to those with the double data type. But only one thing you need to keep in mind is the lower precision level than the double data type. Here let me show you an example. C is equal to A plus B. And now let's run this section. And there we go. The answer C is also of single data type. When you are dealing with single data type, you need to deal with the potential for data precision loss as compared to double data type. This can impact sensitive calculations, leading to different outcomes than those obtained with the double data type. And that is so obvious. But here, single is beneficial for enhancing performance in the scenarios where involvement of large datasets is there. As it uses less memory than the double, it makes the operation faster and more efficient. The single data type is ideal for the task like graphic rendering, where the speed is more important than the pinpoint accuracy. Now let me show you a small example of that. Here we are creating a random image of black and white dots, and then here we are showing the image. Now let's run this thing, and the large image has been created. So this is one of the example of single data type. And now we are going to explore another data type, and that is integer type. Let's bring it a little bit up. Now, understanding integer type is essential. Basically, MATLAB supports several integer types, and that are both signed integer and unsigned integer. And these integers are crucial for discrete data operations and when working with the whole numbers, especially in digital signal processing. In MATLAB, integers are stored as whole number without any fraction point, and the previous two data type that we have seen, double and single, these have been stored with fractional point. Here if we talk about C, when we open this, it has been stored with a fraction number. The integer data type can ranges in the size from 8-bit to 64-bit, and here on the screen you can see all the signed and unsigned integer types. For example, integer 8 spans from -128 to +127, while unsigned integer spans from 0 to 255. This shows the range for that integer type. Now let me show you how you can assign integer type to particular variable. Let's say this k, we are making it as integer 8 variable, and the value assigned to this is 127. Now let's run, and here you can see the class written as integer 8. Let's say if you want to assign integer 64, kk is equal to 127, and let's run, and here you can see it is integer 164. Now this integer type supports the basic arithmetic operations like addition, subtraction, multiplication and division. Now let me show you one of them. Here we are creating another variable j with integer 8, and then we are subtracting j minus k. Let's make it k minus j, and let's run, and we have the value of n as 107 integer 8. But here something important that you need to be very careful of, and that is the problem of overflow and underflow. This is the common issue with integer in MATLAB, overflow and underflow. Now let me show you what is this problem. Now here integer 8 can show maximum value ranges between minus 128 and plus 127. And here what we are going to do, we are going to create m as j plus k. They both are integer 8 variable, and the addition of these two becomes 147. But integer 8 can only show the values that ranges between minus 128 to plus 127. So now let's see what happens when we run like this. And here you can see the result of m is 127. It does not show 147, and this is called overflow. Now let me show you again one more thing. Now here we have k. They both are 127, right? And we are going to create another variable m1 is equal to kk plus kkk. Now we don't want to see this, right? So we are going to just hide them all so that we can have the result at on the top. And now let's run. And here we have result 254, because the range of integer 64 is much larger than the range of integer 8. Now if we talk about the performance of this data type, then integer calculations are usually faster and more memory efficient than the floating point calculations. And this is especially beneficial in embedded systems where resources are limited. So choosing the right data type for right application, that is the key for better programmer. And that is why this type of videos has been made either by me or by many creators like me. Now there are varieties of places where this type of integer variables are being used. Now let me show you one of the practical example of this integer. They are commonly used for loop counters and indexing arrays. These are the fundamentals in programming. Let me show you one of the example. Here we have this loop counter, right? When we run this thing, each index have been taken as integer number. And to check whether your variable is of which class, you can always refer this workspace. So I think integer data type is clear to you. So with this, our first data type, that is numeric data type, is completed.